All right, so let's talk about the major parent functions that we're using in this class, and then how you do the transformations. We can reflect them, we can stretch them, and we can translate them. The three main parent functions are, write these down, y equals x squared, y equals the square root of x, and then the newest one, you may have watched the video last night, maybe you didn't, the absolute value of x. So these are the three parent functions that we're working with. We also worked with the plain old line, y equals x. That one's kind of boring. We're not going to use that one as much anymore. These are the three major players right now. X squared, square root, and absolute value. And here's what they look like. First, you can explore any of them by just making a quick table of values to see what happens to y as x changes. But here's what x squared looks like. Think about putting in 0, 1, 2, and 3, and what you would get for y. So if you put in x, 0, 1, 2, 3, what do you get when you square 0? 1 squared, 2 squared, 3 squared. Okay. So that's the shape that you're going to see for the parent function x squared. 0, 0, 1, 1, 2, 4, and 3, 9. So what kind of shape is it? What kind of letter does it end up looking like? If it's going to curve up like this? All right, but what would happen on the other side? What's negative 1 squared? 1. What's negative 2 squared? 4. What's negative 3 squared? 9. Okay? So on the left side, we have negative 1, 1, negative 2, 4, and negative 3, 9. And you see some symmetry here. It does look like a U. So that is the parent function. And if it has been reflected or translated, it will look exactly the same. It will have this movement. Over 1, up 1, back to the origin. Over 2, up 4, back to the origin. Over 3, up 9. That should be the change that you see if it has been slid. Up, down, left, right, or flipped upside down. If it's been stretched at all, which is what section 4.6 gets into, you're going to see some change to that, that increase. Instead of 1, 1, it might be different. It might be 1, 2. We'll see that with some of the examples that we do later this week. So that's it. That's what the parent function x squared looks like. What does the green one look like? Well, let's meet our second parent function, square root. Where does it begin its life, its launch? At 0, 0. And here's how we know. What's the square root of 0? Square root of 1. 1. Square root of, what do you call it? 4. What's the square root of 9? So those are the key points on the parent function, square root of x. 0, 0, 0, 0, 1, 1, 4, 2, and 9, 3. It's a sideways parabola, but we only graph the top half of it. So that's your second parent function. Again, if it just slides or flips, this is the one that we learned about last week that can flip the other way. Remember this? If it was the square root of negative x. Remember that? Say yes. Okay? It could flip upside down if it was the negative square root of x. Or double negative would make it go over here. You remember that? That's where we started our discussion on flipping graphs. And that's where it went. So what we call those, if all these graphs do is slide. Okay, so if you take this and you just slide it up, or slide it left, or flip it the other way. Let's flip it. All right? If you slide them and flip them and they don't get larger or smaller, that's called a rigid transformation. It just moves. It doesn't dilate. 4-6 gets into dilating and changing the size. Now, the absolute value is the third parent function, and this is the one that I showed on a video just last night. We start with 0, 0, because the absolute value of 0 is 0. 1, 1, because the absolute value of 1 is 1. 2, 2, because the absolute value of 2 is 2. On the other side, you have negative 1, 1, and negative 2, 2. So we see symmetry. It grows in this fashion. Right one, up one. Right one, up one. Right one, up one. Right one, up one. So we could say that it's a line with a slope 1. And on the other side, it's a line with slope negative 1. And those are the three parent functions.